Hey guys, Mr. Backerberg here. In this video, we're going to look at solving equations with variables on both sides. So we're going to work on solving this equation. We've got 9z plus 12 equals 9 times z plus 3. So as we look at what we've got happening in this equation, I see that 9 outside of the parentheses on the right-hand side. So we're going to do a little distributive property over there to help us start cleaning things up a little bit. So when I take 9 times z, that's going to give me 9z. And then when I take 9 times 3, that's going to give me plus 27. Now, I haven't changed anything on the left-hand side yet, so we have 9z plus 12. Now, I want to get my variables on the same side. And normally I say I like to move the smaller of the two variables, but if we look, both of these variables are exactly the same size. So it really doesn't matter which one to move. So I'm going to subtract 9z from the left-hand side. And whatever I do to the left side, I also have to do to the right side. So I'm going to subtract 9z over there. Now on the left-hand side, when I take 9z minus 9z, that's going to cancel out. And on the right-hand side, when I take 9z minus 9z, that's also going to cancel out. So on the left-hand side, we have 12 left over. And on the right-hand side, we have 27 left over. So now we have an equation that says that 12 is equal to 27. And mathematically, that doesn't make any sense. 12 can't equal 27. They're not the exact same number. So something weird is happening in here. If, as you're solving an equation, you get a mathematical statement that doesn't make any sense, then that means that your equation has no solution. So because we're trying to say that 12 is equal to 27, that's something that doesn't make any sense. We say this equation has no solution. As we take a look at our next example, on the left-hand side, we've got 3 times 2a plus 4 equals 6 times a plus 2. I see that we have distributive property to take care of on both sides. So I'm going to start on the left-hand side. 3 times 2a is going to give me 6a, and 3 times 4 is going to give me plus 12. If I distribute the 6 on the right-hand side, 6 times a is 6a, and 6 times 2 is plus 12. Now we're going to get our variables on the same side, and again, we have variables that are the exact same size, so it really doesn't matter which one we move. So I'm going to subtract the 6a from the left-hand side to get that to cancel out, but when I do that, I also have to subtract 6a from the right-hand side, and those cancel each other out as well. So we get an equation that says 12 equals 12. Now, in the last example, we got a statement that didn't make any sense, and that meant that there were no solutions. Here, we're getting an equation that is true. 12 is equal to 12. When you get a true statement, then this equation is called an identity. And what that means is that you can safely plug in any number you want for the variable, and it will always work. So what we can say in here when we've got an identity is we can say that the solution is all real numbers. And again, what that means is we can safely plug in any number we want for our variable, and the left side will always match up with the right-hand side. One more example I want to run through here. So we have 7w plus 3 equals 5w plus 3. We want to get our variables on the same side. I like to move my smaller variable, so I'm going to move the 5w. I'm going to subtract 5w from the right-hand side to get that to cancel out. And whatever I do to the right side, I also have to do to the left-hand side. So 7w minus 5w is 2w. We still have the plus 3, and this is equal to 3. Now I'm going to subtract this 3 from the left-hand side, so minus 3 here and minus 3 on the right-hand side. Now on the left-hand side, that positive 3 and that negative 3 cancels out. On the right-hand side, that 3 minus 3 is also going to cancel out. So we get 2w equals, but we just canceled out that 3 on the right-hand side. But we need to have something over there. We can't have an equation that doesn't have anything on one side. So when I take 3 minus 3 on the right-hand side, instead of thinking of that as canceling out, I want you to think about it as 0, because 3 minus 3 is 0. Now, as we're working on getting W alone, I have to get rid of that 2. So I'm going to divide by 2 on both sides. So the left-hand side, the only thing I have left is W. And on the right-hand side, when I take 0 and divide it by 2, I should get 0 as my answer. Now, I should double check that 0 is in fact the solution. So I'm going to go back up to the top and I'm going to plug in 0. So 7 times 0 plus 3 is equal to 5 times 0 plus 3. I'm going to work out the left-hand side first. So 7 times 0 is 0. And if I add 3 to that, I get 3. On the right-hand side, 5 times 0 is 0. Plus 3 is 3. So we get a matching set of 3's, which confirms that 0 is our answer. That's going to be it for this video. Thanks for watching.